In this video, I'm going to show how we do problem number 3 on the Chapter 5 Thermodynamics worksheet. These problems work the same way that number 2 would. I'm just doing number 3 instead of number 2 so that I can show you sort of the two ways that you can tackle this problem. So we are given 25 grams of a substance, so we have mass. We are given an initial temperature, and we are looking for the final temperature. We are also given an amount of heat, Q. So the difference between all three of these, A, B, and C, is which substance will be heating. So in A, it's 25 grams of copper, and B, it's 25 grams of styrofoam. So we're going to use the equation Q equals SM delta T to tackle these problems. In this S is the specific heat capacity, which you would look up. Specific heat capacities sometimes are in joules per gram degrees Celsius. You can also find them as molar heat capacities, where the units would be moles per gram or joules per mole degrees Celsius. We are only going to work with the ones that have units of joules per gram degrees Celsius. So you just have to look these up. For copper, S is 0.385 joules per gram degrees Celsius. And for styrofoam, S is 1.4 joules per gram degrees Celsius. Okay, so the two different ways you can solve this problem relate to how we handle this delta T component. In the first method, we're going to rearrange the equation and solve directly for the delta T. If we rearrange our equation and solve directly for delta T, the change in temperature, it's equal to Q over SM. Then we can plug in our information. Q is 2,350 joules of heat. So I sort of did a little shortcut here, and I converted using the fact that 1 kilojoule is 1,000 joules. So we convert our heat to joules. If it's in joules, then you don't have to do that conversion. But if it was in kilojoules, we need to get it back into joules, because the specific heat capacity, S, has units of joules, and we want them to cancel out. All right, then the specific heat capacity, 0.385 joules per gram degrees Celsius, and the mass, 25 grams. Okay, so we can see that joules will cancel out and grams will cancel out. And this will give us an answer in degrees Celsius. So when we solve for delta T, what we end up with here is 244 degrees Celsius. This is not the final answer, though, because the question is asking for final temperature, not the temperature change. What we solved for was just the temperature change. So this tells us that the temperature increased by this much. So the final temperature is going to be equal to the initial temperature plus that change in temperature. So our final temperature is the initial temperature, 27 degrees Celsius, plus our increase in temperature to give us a final answer of 271 degrees Celsius. So that's one way you can use this equation. The other way we can use it is by substituting TF and TI into the initial equation. So we'll do that for styrofoam. Q equals SM, and then delta T is TF minus TI. Then we'll plug everything in. Our heat was 2,350 joules. Our S for styrofoam is 1.4 joules per gram degrees Celsius. Our mass is 25 grams. Our final temperature is what we're solving for, and our initial temperature is 27 degrees Celsius. Okay, we will divide both sides by this 1.4 joules per gram degrees Celsius times 25 grams. Joules per gram degrees Celsius times 25 grams. And joules cancels out, grams cancels out, all of this cancels out. And once again, we will be left with an answer in degrees Celsius. So what we'll get here is 67.1 degrees Celsius equals TF minus 27 degrees Celsius. And then we just add this to both sides. And our final answer is 94 degrees Celsius. Both of these ways of using the equation are equally valid. Some people prefer to just put the TF and TI into the equation, and some people prefer to use and solve for the delta T first and then do a second step where they find the actual final temperature.